Hello, and welcome to today's discussion of object oriented programming and the creation of classes. My name is John Maxwell, and I am an instructor with the Arupe Virtual Learning Institute. Well, before you, you see a public class account, and basically, the account is a blueprint for many accounts that may be created. And I've chosen a broad generic name account. It applies to almost any business or organization that creates an account of perhaps customers, perhaps they're called students in schools, but an account is a broad generic thing. And it serves as a blueprint for multiple instances of the account that are or could be created. Now, I could have an account, you could have an account, and other people could have an account, but all share the properties as defined in the public class account file. Well, I mentioned the word properties. There's two elements to a class. This is a public class account. One are the properties, which maintain the state of the object, and the other are the methods, which define the behavior of the object, what you can do with an account. So, an account could be a lot of different things, but like I've chosen just three for simplicity: amount, account number, and name. And note the word private, meaning they cannot be accessed outside the class. Okay. And that's a general idea in Java class creation called encapsulation, which indicates that everything that a class can do is encapsulated within the open and close braces of the class, and that the class is responsible for maintaining its own state. So, any changes to those instance variables need to be done through methods. It cannot be done externally by changing, say, the account amount or account number without using a particular method as defined in the class. So, the first thing to understand is that there are methods, and the first one we're going to look at is or are constructors. And notice the constructors share the same name as the class, okay, and that's always the case. And they don't have a return type. So there's no void or double or int there. I suppose one could think of it as at the end of the method execution, the object is created. So it kind of returns itself a new account. You have one which you should always build in, which is the default constructor. It is a parameterless constructor, and the purpose of it is to set each of the instance variables to their initial values. And even though it's somewhat duplicative, here it's defined with 0 and an empty string, it's once again given those values at the completion of the default constructor. So you should always put one in, okay, without a complicated answer, so that you can actually define how the default constructor works. We also have a constructor that takes three parameters, b, num, and name, and sets the instance variables equal to the values that are sent in through parameter passing. So amount is equal to b, and account number is equal to num, and this dot name, which refers to the instance variable, is equal to the parameter value name. With two things sharing the same name, and in this case capital N name, in order to differentiate the instance variable from the parameter variable, we use the this dot. This refers to the object itself. So I'm going to split a screen a little bit here and show you how this works, we have the account constructor, and here on line 5 we're calling the constructor on line 15. So this is referring, and I give it B, the amount 30, and the account number 1, and the name James. Then I create another account with a bigger balance. Of course, it's for me, 1,000. My account number is 2, and of course, my name is John. So we have two accounts created with the constructor here on line 15, and one account on line 10 over here created using the default constructor. So we have three accounts, and I've run it down below, and it prints out P and Q, and does not print out Z. But if it did, it would just print out 00 and an empty string. And that's how it works. And of course, P does not equal Q because they have different account numbers, so it prints out false. So there's a pretty good example of using a constructor here, using the new keyword to indicate that you can create an object with that way. And each one of these things, P, Q, and Z, to get with the way we describe them, are called instances. So that's something we want to talk about too. On line 20, begin a series of accessor methods. Again, these are private in scope, and so in order to get information out, okay, such as right here and right here, we have to use accessor methods. So when we say get amount, return amount as specified by the double return type, and get account, return account number, and as specified by an int, and again get name. And they're simply to access information about the class. So I'll run this again and point out that it outputs 2, which is the account number, and then the amount. Okay, so the accessor methods are built in order to access the private information. Remember the principle of encapsulation? It maintains its own state. The state is in the instance variables, and they're private. So in order to get information about them, developers create accessor methods. And of course, in order to change them, we have mutator methods, which allow a value to come in and change the instance variable. So in comes B, and then the amount, which is the instance variable, gets changed to the value of B, and so on. Set number, set name allow for the update of the instance variables, and they're generally known as modifier or mutator methods. And in the vernacular, sometimes accessors are called get, and mutators are called set. Get and setters. Okay, they're good names for accessor and mutator methods. So that makes sense. The principle of encapsulation dictating that in order to get information out of the class, you have to use a method, and in order to get information or put information into the class or change the instance variables, you have to use a mutator method. There are two other methods that I think deserve consideration, so we need to put them right in. One is a toString, which returns a string representation of the object. And you can see account number 1 belongs to James with a balance of, and you can see the beginning of it here. And what happens is the toString method is automatically called by the systemout.println method. Okay, so if it's not put in, note the result. let's run this trial program again, and we'll see. We'll call it a driver. And we want to reaffirm that each of these accounts that we created using the new keyword are itself a reference to a location in memory. They're known as reference variables, like objects that we've covered before, strings, arrays, and those type from the first semester. We get the memory address in hexadecimal. So this kind of proves that somewhere there's a two-string method providing the hexadecimal address. And to peel back the curtain, we want to tell you it's in the capital O object class, which is the class from which all other classes are derived. So it's the grandma or the granddad of all classes ever created in Java, the capital O object class. So let's uncomment this because that's not typically very helpful to have that type of output. And notice one other thing. So the toString, the capital O object class also has an equals method, which is wise and beneficial to overwrite for every class that you create. And the equals method takes an account here, X, and compares the account numbers. Now, the equals could be different for every type of class you develop. In this case, we're trying to develop whether the count is the same, okay, for two accounts. And, maybe we want to do something different with another class, but take a look. P dot equals Q, and the answer is false, but what are we comparing? Well, first of all, P, or rather Q here, becomes X. X is an alias of Q. The memory address of Q is copied over to X, and note X dot account number. Now, you don't have to go X dot get number or get account up here. You could, but when you're in accessing the private member of another instance of the same class, you don't have to use the accessor. So let me repeat that. When you're accessing a private member of another instance of the same class, you don't have to use the accessor. No, I had to work through that a little bit. X dot account number, okay, and comparing it because they're integers, we're saying this, and this refers to P here. P is the object itself in memory, so it can always self-reflexively refer to itself using the this, and we used it up above in the constructor to refer to the particular instance variable name, capital N name. And in this case, we're using it to refer to the account number of this object, which refers to P. And so there's a simple explanation of this. And again, it would return false. So let me just run this again and say, great. Okay. Now, I'm about done here, but I wanted to show you one other thing. Here we have public class account, and it provides a blueprint for any account that's created. It has properties and methods. The methods include constructors, which allow you to create an instance of the class, accessors, which allow you to get information out, and modifiers, which allow you to change the state or instance variables of the class. So it's certainly a good blueprint, but it can be extended. And we'll cover this in the future, although it's not part of the AP curriculum this year. It was dropped out. But public class savings extends account. So what happens is we want to go a little further with count, and in the banking example, we're going to create a savings account, and the savings account adds the rate and the term, and we can construct a savings object and get rate and get return. And what happens is it has all the properties of the account class plus additional features that you add to the savings class. But I want to show you that, this is called inheritance, all right? And it allows you to take a general concept like account and through the extension into child classes be able to refine it so that you can adapt it in many different situations. So obviously the corresponding class to savings would be checking, which also extends account and may have some other private instance variables, and it may have money market or any other type of account that the bank offers or the customer gets. And so we'll go back to account and conclude here. I hope this was helpful, and thank you very much for watching.